Hi, Chris Chinnock here. It's CES 2026. I'm at PepCon, and we're with a company called MetaOptics, and they are one of the first companies that's actually produced useful optics for projection and other applications. So let's talk about it.
Hey Chris, thanks for coming by. So I would do a quick introduction of our company. So MetaOptics is Singapore-based metalens company. We design and fabricate metalens in its scale. All right. So the advantage of metalens is basically to reduce the need for bulky lenses that you see in consumer electronics today, be it for imaging or sensing or distant recognition, facial recognition, fingerprint recognition. Things like that can be further reduced with metalens. So metalens, in short, is actually a flat lens or a 2D lens. It is made up of many circular pillars of varying diameter of different refractive index.
Right. These are nanometer scale pillars.
Nanometer scale. So the smallest feature size that we have on our metal lens is 80 nanometer.
80 nanometer?
80. All right. 80. So we are using a semiconductor process to produce it. So using a semiconductor process gives us high yield, high throughput.
Which process are you using?
So we are using a DUV immersion lithography.
DUV, okay.
So we are using 45 nanometer lithography too. Okay, and then the rest of the process are standard. Basically deposition, lithography, and then etching.
Okay.
All right, and then we dice it. It's a very standard process. So with this, 80 nanometers has, if you look in the chip today, they are in 2 nanometers, 3 nanometers, 4 or 5 nanometers. So what we do here, if 80 nanometers, is something that has been done long ago.
Right. So what kind of design rule do you need at the silicon fab though?
So for our design, yeah, we design it. We are using American software. We're using ANSYS software to design our metalens.
Okay.
And then we will work together with a foundry in Singapore to produce metalens on a 12-inch glass wafer.
Is it Global Foundries? Are you working?
No, we are working closely with the government. The Singapore government has a pilot line in Singapore.
I see.
So we are using their line.
I see.
All right. Because the bottleneck with working with foundries today is that we do not have enough volume today for them to stop at an entire line to work on glass. Because traditional chips are using silicon wafer. Chips are using silicon wafer, we are using glass. So we produce metalens directly on glass. So that's our edge. Okay. So over here, this is actually
and how do you etch the glass?
How do we etch the glass? We use etching machine and etching equipment.
Is it a dry etch, wet etch, electron beam etch?
It can be both. It can be either dry or wet. And some of the processors requires to do both.
I see. Okay.
So yeah, Chris, you are a semiconductor guy.
Yes.
Yeah, so this is the 12-inch wafer that we produce in Singapore.
Okay.
All right, so the first generation of lenses is actually circular. So what you see here is actually from our first generation of metal lens. This you can see over here is actually three metal lenses on a single lens.
Yes, they're very tiny. They're like
RGB.
Yeah, they're like 0.5 millimeter or something. What's approximately?
It's about 2 millimeters.
2 millimeters.
2 millimeters each.
Okay.
Yeah. So this is the new product that we are launching. This is a rectangular metal lens. So traditional lenses are all circular, but we want to show the world optics can be rectangular.
Right.
And with our rectangular, we can actually maximize the pixel size, the pixel area on the sensor, and therefore we have a better image, better quality. We only use is actually red, green, and blue. Okay, so there's actually 4 products here. So there's actually 1, 2, 3, and 4.
So what are the barriers for taking this to larger commercialization? You said glass fabs is one, right?
Yes.
What else?
So right now, our capacity in Singapore, we can produce a couple of millions, depending on the design. We can produce about 30 million lenses a year. So 30 million lenses a year. So if the demand requires, if we have higher demand, we can actually go to the fab. So we are working in some of the fab in Taiwan. When we have the volume, then we can start to talk again. Because they won't be able to stop an entire line right now that's working on chips. There's a demand for the chips.
Of course.
And they can't stop it. Right. If we have the demand for metal, and this is something using the similar equipment that produce chips, we can produce optics. This is a new business for them. Yeah. So
yes, but silicon fabs, can they really be converted to glass?
Yes, they can. So our company has proprietary IP in fabrication. So this can be transferred to them.
Okay.
Right, and it's not a difficult task. It's not.
Okay.
Yes.
And how about all the chemicals and materials for processing this? Are those semiconductor fab compatible?
Yes, they are standard materials. They're not materials that are new. So we use glass that is off the shelf on the market, and then we use materials like amorphous silicon.
Yeah.
And we use materials like titanium dioxide or silicon nitride. So these are materials that the fab has been using for a long time now. Yes.
Okay.
So we are a semiconductor optics company. They produce metalens using optics using semiconductor process. So this is the key from our company.
Yeah.
Right. We are in the lens making business, but the important thing that we want to show, why do we make all these products, is to show that the lens is actually working and has different applications.